Welcome to a lecture on radioactivity by Ms. A. Shirley Jones, Associate Professor, Department of Physics of V.V. Sanga's Veerashaiva College, Ballari. Radioactivity is the second chapter in the paper 6.1 for Bsc VI Sem students. Radioactivity was discovered by Henry Becquerel in 1896. This discovery was an accidental. Henry Becquerel, on one off weekend, kept some photographic plates in the chest of drawer of his table and went away. Later, on Monday morning when he returned, he found that the photographic plates were blackened. He thought that this blackening of photographic plate is due to the incidence of some particles. He found that there are certain elements kept in the same chest of drawer. He naturally thought that the particles were coming from these elements. So, later, on further experimentation, he found that there is an emission of particles coming from certain kind of elements, and that led to radioactivity. So, radioactivity is a nuclear phenomenon of spontaneous emission of radiations from radioactive substances. It is also defined as the spontaneous change in the composition of nucleus by the emission of elementary particles or radiations. Now, the particles which are coming out of the nucleus were found to be of three in nature. Those are called alpha particles, beta particles, and gamma particles. Now, alpha particles, beta particles, and gamma particles are not emitted by a nucleus all at a time. Each nucleus emits a kind of radiation. Now, let us see what are these particles. Now, alpha particles is considered to be helium nucleus, which is having a positive charge and is deflected by the electric and magnetic. Next, later studies showed that beta particles are electrons, negatively charged, which are deflected by both electric and magnetic fields. And gamma particles are neutral particles. The various characteristics of alpha, beta, and gamma particles are shown below. Now, alpha particle is a helium nucleus, which is positive in charge, which travels with less velocity than the velocity of light. But it has got a high ionization power. Now, what is ionization power? Ionization power is the ability of a particle to split a neutral atom into positive and negative ion. Now, alpha particles have got a low penetration power. Minimum millimeter of aluminum foil can stop alpha particles. Now, alpha particles have got low range and low absorption power. What is range of an alpha particle? Range is the maximum distance an alpha particle or any particle can move or travel before it loses all of its energy. And of course, the absorption particle. These are electrons. These are the particles possessing negative charge. They travel with approximately with the same velocity as that of light. They have got low ionization power. Why it is low? With beta particles. Beta particles, because they travel with the almost equal to the velocity of light, spend very less time in the vicinity of a neutral atom. So naturally they ionize less. So it is beta particles have low ionization power. Now, beta particles have got high penetration power. They can penetrate few centimeters of aluminum foils. Now, they have got high range because their energies are high and they have got high absorption power. Gamma particles, these are neutral particles without any mass. They travel with the velocity of light. They have very, very low ionization power. They have very high penetration power, and they have high range and a very high absorption. Now, radioactivity is something to do with the nucleus and the transformations it is undergoing in order to emit these radiations. Because radiations are coming out of the nucleus, we say that the nucleus of that radioactive element disintegrates. When the disintegrations coming out of the nucleus were observed, various laws were formed. One of the laws which has much importance is decay law, which can be stated as at any instant of time the ratio at which the number of atoms disintegrate is proportional to the number of atoms present at the original at that instant. I repeat, decay law can be stated as at any instant of time the ratio at which the number of atoms disintegrating is proportional to the number of atoms present at that instant. Let n0 be the total number of atoms present at the time t is equal to 0 in the sample. Let n be the number of atoms left undecayed at any instant of time t. Then, and let dn be very small number of atoms decaying in the interval of time dt. Then according dn divided by dt is proportional to n. We have assigned a negative sign to the ratio dn by d2 because the number is decreasing. Therefore, we can write dn by dt is equal to minus lambda by n, where lambda is a proportionality constant. Here it is called as decay constant. Now we can solve this equation, that is dn by n is equal to minus lambda t. Now we integrate, and the integration limits we can take for a time interval 0 to infinity. Then we get log n to base c is equal to minus lambda t plus c. Now considering the original or initial conditions, that is when time t is equal to 0, when the disintegration has started, let n0 be the number of atoms present. Then substituting, we get the constant c as log n0e. Now substituting in this equation 2, we get log n to base c is equal to minus lambda t plus log n0 to base c. Now solving this, we can get log n to base c minus log n0 to base c is equal to minus n by n0 is equal to e minus e to the power of minus lambda t, or n is equal to n0 into e raised to minus lambda t. This is equation 3, which is mathematical expression of decay law. Now, according to this equation, the number of atoms, now let's try to read this equation. The number of nuclei present at any instant is equal to the number present at time t is equal to 0, and it has got an exponential factor. You know that this number can become, n can become 0 only when time t is equal to infinity. So this is an exponential curve. It indicates an exponential curve. So let us try to get some statistics out of this. Let us put t as is equal to 1 over lambda. Then this equation becomes n by n0 is equal to e minus 1, that is 1 over e, or n by n0 is equal to e to the power of minus 1, which comes out to be 0.368. Therefore, n is equal to 0.368 n0. Thus, we can define decay constant of a radioactive element as is defined as the reciprocal of the time during which the number of atoms decreases to 1 over e times their value. Now, let us see that When this number can become 0, it becomes 0 only when t infinity. So it is a very large time, nobody lives up to that time. So a time is chosen which is called as half-life, and we define it as the time taken by the radioactive element to become half of its original value. That is, half-life of a radioactive element is defined as the time during which half of the original amount of the radioactive element decays. Let us consider n is equal to n0 e raised to minus lambda t, and let us put for small t is equal to capital T, symbolizing half-life. Therefore, we get an equation n0 by 2 is equal to n0 e raised to minus lambda capital T. Then, therefore, e raised to minus lambda capital T is equal to half, or e raised to lambda t is equal to, or lambda t is equal to log 2 to Bc, or capital T is equal to 0.6932 divided by lambda, or we say here that capital T, the half-life of the radioactive element, is inversely proportional to the decay. Now we have another parameter called as mean life of a radioactive nucleus. Now we see that these radioactive nuclei, when we look at the radiations coming out of the radioactive nuclei, now they have a different lifespans. So we have to take the average. That's why this parameter is defined, and mean life of the radioactive nucleus is defined as the total lifetime of all the atoms to the total number of atoms present. Therefore, mean life is equal to total lifetime divided by total number of atoms. Now, let n0 be the number of radioactive nuclei in the beginning at t is equal to 0. Let n be the number of nuclei present at any instant time t is equal to t. Let dn be the number of decaying nuclei in time dt. dn be the number of nuclei decaying in time dt. Now, if dn atoms have the life between t and t plus dt, then this time let it be very small. Therefore, the total lifetime of dn atoms or nuclei is dn into t. But the total life of all the atoms is equal to integral 0 to infinity t into dn. There's a plus written there. It is t into dn. Now, mean life is symbolized by the letter tau. Therefore, according to the definition, tau is equal to 0 to integral 0 to infinity t into dn divided by n0. Consider n is equal to n0 e raised to minus lambda t. Therefore, dn by dt is equal to minus lambda into n0 e raised to minus lambda t. Then dn is equal to n0 into e raised to minus lambda t into dt. Therefore, tau is equal to integral 0 to infinity t into lambda into n0 e raised to minus lambda t dt divided by n0. So we get an equation. Tau is equal to lambda integral 0 to infinity t e raised to minus lambda t dt. And we see that it comes out to be t is equal to 0.6931 tau.